Hello and welcome again to another wonderful adventure in math with Mr. Sims. I'm so happy to bring you today the basics of exponent rules. We won't do a lot of practice on simplifying exponent expressions. We'll have to do that in another video, but this will give you the basic exponent rules so that you kind of have an idea of the rules that you have to play with. There are a number of exponent rules that you have to memorize. Do not try and derive them on the spot. You just need to kind of commit them to memory, and the best way to do that is just practice. My suggestion for you is to get flashcards where you can write the different examples and the exponent rules on it. And today, as you're doing this, please make sure that you have a paper and pen handy so that you can practice anything that we try and do together. All right, without further ado, let us continue on to basics of exponent rules. So first of all, we're just going to start with the most basic thing by just telling you what is an exponent. All right, and so let's go ahead and just grab a pen here. And what I'm looking at is basically what an exponent is let's say I have any base here. I'm going to make my base a. This is the exponent. And what the exponent tells us is that we're multiplying this base times itself this many times, right? So this is a to the n. So to give you an example, let's say I were to do x to the third power. Then my a is my x there, and my n would be my 3, right? So anyway, x to the third power, what that tells me is I'm multiplying this x together 3 times. So my answer is going to be x times x times x, right? Another way you could think of that is, let's say I had the number 4, and I had 4 squared. You've seen this before. What that tells me is that I'm multiplying this 4 times itself 2 times. See? Here's the 2 times, so here's my 1 4 and here's my second 4. And I'm multiplying them times each other and I get 16. So another example, let's say I had 4 to the third power. What that's telling me is that I have 3 4s all multiplied times each other. So, I'm sorry, this is dot. So I have 4 times 4 times 4, which is equal to 4 times 4 is equal to 16. 16 times 4 is 64. So I'd put 64 right here. Okay? So I hope that helps you to understand some of the basics of what it looks like. Once again, this is the base, and this is the exponent portion. Okay? So when we're working with with bases and exponents, it's very important that we pay attention to what the base is, because if you have two things that have the same base, then you can start working with those exponents in really cool ways to simplify it. And we're going to get onto that in the next part here. So without further ado, let's go ahead and start with the first rule. That first rule is going to be the zero exponent rule. And that zero exponent rule, let's go over here to it. The zero exponent rule says that if you have anything at all raised to the 0 power, that it's equal to 1. And if you think about that, it kind of makes sense, right? If I have, let's say, 2 squared, it's telling me that I'm multiplying 2 times itself 2 times. So 2 times 2. If I have 2 to the 1 power, otherwise known as just 2, right? Then it's telling me that I'm multiplying 2 times itself just 1 time. In other words, only 1 2 multiplied times itself. So not 2 times itself 1 time, but just only 1 2 multiplied times itself. And so, well, there we go, 2, right? And if I have 2 to the 0, it's telling me that I have 0 2's multiplied times itself. Well, if I have 0 2's multiplied times itself, I'm just going to have the number 1, basically. It's just going to be 1, okay? So anything to the 0 power is 1. Don't worry if that confuses you. Just remember, if it's to the 0 power, it's equal to 1. Now, that comes in really handy sometimes, because let's say I have a really long expression like 4 times 7 times 3 all to the 0 power. I could multiply that out, but if it's to the 0 power, then I know everything in this parenthesis that's to the 0 power is equal to 1. Does that make sense? It all equals 1. So basically, I don't even have to do all that work of 4 times 7 times 3. It also comes in handy. Let's say I have a whole bunch of ugly expressions in here. Y to the 10th. Let's say I even have x to the m, right? And then 4 to the negative third power, right? And all of that in here is raised to the 0 power. Well, it all becomes 1. How cool is that? Yeah, tell me that doesn't save you some time, right? So that's a 0 exponent rule. So remember that, the 0 exponent rule. That was the most ugly underline I've ever done in my life. All right, moving on to the next section. That's the 0 exponent rule. So here, I want you to try one really quickly on your piece of paper. Pause the video and try this one. What would this problem here be using the 0 exponent rule? So think very carefully. Let me erase that. I messed up. Okay, so if I had this, here I'm going to give you a little bit of a tricky stuff in here. All, let's say, to the 0 power, right? Ignore this stuff here. I can erase it. All right, so now that you have all that right there, what would that be? What would this equal here? Okay, go ahead and give it a shot. Pause the video and give it a shot. Hopefully you paused the video and gave that a shot. And when you calculated this, what was the answer you got? Well, all of this simplifies simply to 1. So I have 1 times my 3, which equals what? 3. Ta-da! Isn't that great? Isn't that great? That's so much fun. So anyway, that's the power of the 0 exponent rule. It's a wonderful, wonderful, wonderful rule. You're going to love it because it's going to make things simpler in the future. We don't do a lot with it early on, but we might do something with it later on. So moving on to the next one. The next rule is, that was one you should have put on a note card, by the way. So power rule. The power rule is this rule. It says that if you have a to the m, right? And that a to the m is raised to the n power. This is one of the power rules. It's called the power to a power rule, actually. And it's that it equals a to the m times n. Now, let's actually examine this a little bit. That might not mean a lot to you right now. That might look a little scary. So let's just go ahead and break it down. Let's put an example in that we could figure out easily. Let's say I had x squared, and I'm raising that to the 3rd power. What I'm doing here is I'm taking this x squared and I'm saying it's multiplied times itself 3 times. So let me get my x's, my x times x. That is x squared right there, right? X times x is x squared because it's saying I have 2 x's multiplied times itself. So that's x squared. But I want how many of those multiplied times themselves? I want 3 of those. So I'm going to make another x times x and yet another x times x. And what I get is, here's my x squared cubed. I have 3 x squareds multiplied times each other. And if you do that, you realize that, hey, all these x's are just multiplying times each other. It's basically 6 x's. There's 1 here, 2, 3, 4, 5, 6 x's all multiplied times each other. So as a result, I could just call this x to the 6. Well, what just happened there? If I got x to the 6 as my final answer when I expanded it here and then I simplified it, if I got x to the 6, what gave me that? Well, as you can see, it looks like I multiplied this 2 times this 3. But you never want to just do one problem and take its word for it when you're deriving something like that. You always want to try it out with some other stuff. So let's go ahead and try maybe, let's go x to the 4th, right, squared. Let's see if that works. So what I'm going to do is right here, I'm going to do x to the 4th. So 1, 2, 3, 4. 4 x's all multiplied times each other. Please excuse those dots, right? And then I'm doing that squared. So 1, 2, 3, 4. Another one. So I have 2 groups of x to the 4 multiplied times each other. Well, obviously all those x's are just basically multiplying times each other, so I end up with 1, 2, 3, 4, 5, 6, 7, 8 x's in total, all multiplied times each other, which is known as x to the 8th power. Hey, did it seem to work? Yes, it did, and that is a wonderful thing for us. You don't have to do it with just variables. I'm sorry, that is the ugliest 8. Let me try and fix that. So there we go. That's a beautiful 8. Beautiful. I love it. Okay, so you don't have to just do it with that. You can do it with numbers too. Let's say I had 3 to the 3rd power, right, times, not 3 to the third, 3 to the third power, that raised to this, let's say the second power. Let's see what happens then. So I'm going to just expand it out. I end up with 3 times 3 times 3, right? That's 3 squared. And I have two groups of those multiplying times each other because I'm multiplying that times each other twice. So 3 times 3 times 3. And that gives me how many 3's all multiply times each other? Well, it looks like 6, right? So that ended up being 3 to the 6th power, right? When I simplified all that, it ended up being 3 to the 6th power, okay? Does that make sense? And we like to generally go down, but I just did it this way because I was running out of room at the bottom. So 3 to the 6th power is what that ends up simplifying to, okay? Once again, the 2 times the 3. Once again, the 2 times the 4. So in this case, if you have a to the m to the n power, then you have equals a m times n, okay? A to the m times n. So that's called the power to a power rule. That's another name to it. The power power to power rule. Sorry about the penmanship. Power to power rule. All right. Okay. So hopefully that helped with that one. Let's go to our next rule. Once again, this is another one that you should put on a note card so that you just have some different examples that you can think through. It's really nice to refer to when you're doing homework and things like that. The faster you commit it to memory, the easier exponents are going to be to you for you. Don't wait till right before the test to try and commit it to memory, okay? So here's the negative exponent rule. The negative exponent rule says that a to the negative n is equal to 1 over a to the n. I'll write that down. A to the negative n is equal to 1 over a to the n. Now that just looks scary. I'm just telling you that's just straight. So here we go. If I let me go ahead and put this in easier terms. Let's say I have x to the negative 5. What it's telling me is that this is the same exact thing as 1 over x to the 5th. Right? That's pretty cool. What it's telling me is that if you have a negative exponent, you can put it on the other side of the fraction bar, right? Assume there'd be a fraction bar of 1. And what I can do is I can put it on the other side of the fraction bar and then make this number, whatever it is, positive. So, for instance, let me say I had x to the negative 4. What I'm saying is that that is the same thing as 1 over x to the 4. Does that make sense? So another example would be if I had, let's say, the number 3 to the negative 2. If I had 3 to the negative 2, what that's telling me is it's the same thing as 1 over 3 squared, which is the same thing as 1 over 9, because 3 times 3 is 9. Okay? So that's what the negative exponent rule says. It says that wherever it is, that you can flip it on the other side. But here's another cool thing. Let's say I had 1 over x to the negative 2. If I had that, then what I can do is I can actually flip this to the other side of the fraction bar. And this actually becomes x squared. How cool is that? Yeah. Crazy fun, right? So anyway, so hopefully that is making a little bit of sense to you. Basically, whatever side that negative exponent is on, you can flip it to the other side of the fraction bar and make it positive. And that's going to come in crazy handy as we do some other fun stuff later on. So make sure you definitely know the negative exponent rule, okay? Here, I'll give you another example real quick. Let's say I had x squared, right? Let's say I had x squared y to the negative 3. Then what I would do is I would take this x squared, I'd leave it where it's at, and I would put the y to the other side. You never can leave a negative exponent in your final answer. Whatever final answer you get has to have all positive exponents. You notice this one's a positive exponent, so this would be my final answer here. This would be my final answer. It must have a positive exponent when you are done. This one here would be my final answer because generally speaking you want to simplify it if it's got if you can simplify it easily like that. This one here would be my final answer because, once again, all positive exponents. So if you see a negative exponent, move it to the other side of the fraction bar and then make it positive. Does that make sense? All right, moving on to the next one. Hopefully you're getting, oh, here's one for you to try. Ready? Let's say I had x to the negative 3 y squared. What would that one be? What would that one be equal to if you were to simplify it? Go ahead and pause the video and try. Hopefully you did, and if you did, you got y squared over x cubed. Okay, once again, these are very basic problems. I'll make another video where you actually have to simplify some really cool stuff, but for now we are just trying to get the basic rules down for you. Once again, do not assume that you know these just even by watching the video. Even if you just practice them, what you need to do is commit them to memory. I would put them on note cards and then really commit them to memory. All right, moving on to the next one. Let's go on to the product rule. Woohoo! This one's fun. So the product rule is a to the m times a to the n is equal to a to the m plus n. And you thought algebra wasn't exciting. So here we go. If you have this right here, what you're doing is basically it's saying if you have something with the same base, and this is very important, it has to be the same base that and they're multiplied times each other, you can just add the exponents, which is crazy cool. So let's say I have x squared, right? X to the 4th. I can actually take, if they're both multiplied times each other, I can take that and make it x to the 6th. Now you might be thinking, no, and I'm thinking, yes. So let's look at it here. Let's go ahead and take this x and expand it out. This is x squared, right? Because I have 2x multiplied times each other. And then this is going to be x to the 4th because I have 4 x's all multiplied times each other, right? And if I have those things multiplied both those groups multiplied times each other, then I have 1, 2, 3, 4, 5, 6 x's all multiplied times itself, which makes it x to the 6. Because I have 1, 2, 3, 4, 5, 6. In other words, I have x multiplied times itself 6 times, making my final answer x to the 6. And once again, I got that much simpler if I just remember the rule that a to the m times a to the n is equal to a to the m plus n. In other words, if you have the same base multiplied times each other, then you can just add the exponents. So I get x to the 6. How cool is that? Pretty cool, huh? All right, let me give you another example for you to do then. Why don't you go ahead and try this one? Let's say I had x to the 4th. Ooh, let's do this. X to the 4th, y to the 3rd, x. Yeah, that. Let's do that. Let's simplify that one. So if you were to simplify that one, go ahead and pause the video, give it your best shot. All right, hopefully you paused the video and you were able to get this one right. So let's see. So we have x to the 4th, y to the 3rd, x. Well, can I combine these two here? Hopefully you realize you could not, because these are not the same base. X and y are different bases, so these cannot combine. However, this x and this x can. So what I'm just going to do is I'm just going to show you that I'm just going to move the x to this side, and we can do that because it's multiplication, and with multiplication you can move stuff around like that. So I have x to the 4th, x, y to the 3rd. And so what I have here is x to the 5th. Remember, if there's nothing written, it's assumed a value of 1. So x to the 4th times x to the 1st is going to give me x to the 5th. And then I have y cubed. Now I want you to think for a second, what is the next step? I'll give you about 10 seconds to think about it. Hopefully you realize there is no next step. That's it. This is actually as simple as it gets. You can't simplify anymore because the bases aren't the same anymore. So that's as simple as it gets. That was a trick question. All right, moving on to the next one. Let's see. Let's say we had, I'm going to give you a fun one. Let's say we had x squared y to the negative 4, x to the negative 3, y to the 7th power. All right, go ahead and give this one a shot. Don't forget to simplify it all the way down to its simplest form. Pause the video, give it a shot. Are you pausing? All right. Hopefully you were able to pause and do this, and if you did it, what you came up with was, once again, you could move the stuff around because it's all multiplied times each other, right? So I have x squared, x to the negative 3. Well, I can add these together, and I should get x to the negative 1. And I should get y minus 4 plus 7. Negative 4 plus 7 is going to give me a positive 3. So I get y to the 3rd. And you might have thought that that was your final answer, but is it? What did we say earlier about a negative exponent being in your final answer? Hopefully you remember back in the other part that we were looking at when we were doing the negative exponent rule that you can't have a negative number in your top. So what you have to do is move it to the other side of the fraction bar. So here I would take this x to the negative 1 and I would change it to this. Y to the 3rd once again stays on top and it becomes x on the bottom. Once again to the 1st power. But you don't have to write that 1st power. It's assumed if you just leave it x, okay? So y to the 3rd over x is my final answer. I don't like having that little, whatever, I'll just leave it. I don't like having that one there. It kind of annoys me, but you get the idea. So y to the 3rd over x is perfect. Haha! All right, let's go on to the next rule. So, where is that rule at? There it is, over here, over here. Over here, that's the right one. So we have the quotient rule. The quotient rule is a fun one too. So the quotient rule says if I have a to the m over a to the n, that I can do something fun. Just like the product rule, where you could, if you had a to the m times a to the n, you could just add them. If you have a to the m over a to the n, or a to the m divided by a to the n, you get to do subtraction. Now, it's very important that the bases, once again, are the same, and you get a's to the m minus n. And let's see if this makes sense. Let's think if it really does here. So let's say I had, for instance, x to the 5th power, right, over x squared. If I expand this out, I'm going to end up with x times x times x times x times x. That's 5 x's all multiplied times each other. And I have 2 x's on the bottom, right? Now, that's x squared, and this is x to the 5th, right? And these should all have dots in between them. Boop, boop, boop. Okay, so now that I have it expanded, I can actually see, I can start canceling stuff out. And if I cancel both these things out, I end up with this beautiful x to the 3rd on top. There's 3 x's all multiplied together, so that's x to the 3rd. And as you can see, the easy way to get that was go 5 minus 2. Once again, 5 minus 2 is x to the 3rd. Did that make sense? All right, let's do another one just for kicks and grins. Let's say I have x to the 8 over x to the 3rd power. All right, go ahead and pause the video and try and solve that real quick. You can expand it if you need to, but pause the video and try and solve it. All right, hopefully you were able to realize that 8 minus 3 is 5. Therefore, it should equal x to the 5th. However, if you needed to expand it, let's look at how that would have happened. You would 8 x's all multiplied times each other, right? And then all over x to the 3rd, which is 1, 2, and 3, which gives you how many x's left over all together? That gives you x to the 5th, which is what we got just by doing 8 minus 3 equals 5 and putting that as the exponent. Yay! Okay, hopefully this is making sense to you now. All right, let me give you a hard one just because that's just how we roll. So let's say you did let's go x to the 7th over x to, you know what, I need a little bit more room. I'm just going to move over just a hair. There we go, give myself some room. Let's say I had x to the 7 over x to the negative 4. Go ahead and pause the video and give that a shot. All right, hopefully you paused the video and you tried it, and what you should have got was x to the 7 over x to the negative 4. You said 7, let me do it here. I'll do it in red actually, just to, or purple, just to highlight it. 7 minus a negative 4 is going to give me what? It's going to give me a positive 11. So my answer is going to be x to the 11th. Okay, now you might be thinking to yourself, what? And hey, if you're thinking to yourself that, let's go ahead and look at it. I kind of like that purple, but anyway, I'm going to turn back to black for now. And what we're going to do, that is weird. Okay, so I don't like that. Back, there we go, perfect. So we have x to the 11th. Let's actually expand this out. So we have x times x times x times x times x times x. 1, 2, 3, 4, 5, 6, and 7 is x to the 7. And I need to, on the bottom half, have what? Well, I don't need to have anything on the bottom half. X to the negative 4, remember, tells me that this actually needs to go on the top half, because a negative exponent, you flip it to the other side of the fraction bar. So actually, that x to the 4th, negative 4, becomes x to the 4 on top. 3, 4, mind blown. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's x to the, oh, sorry, what am I doing? That is equal to x to the 11th, which is over here, and I don't want to scroll over there, so I'm just going to go bing. It's the same answer. Did we get it? Yes, we did. Yay! I'm going to, we are now going to draw the ceremonial chicken of victory. Yay! I don't know why he's so sad in this picture, but we're just going to draw the ceremonial chicken of victory. Yay! Chicken of victory. Okay, moving on to the next rule. Boom, 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 boom. Power of a product. All right, this is the final rule that we are going to cover in this video. It's called the power of a product rule. And what that is if you have A times B, right? Something multiplied times something else, all raised to the nth power, that you can do something cool with it. You can actually turn that into A to the n times B to the n. It's almost like that gets distributed amongst the inner pieces. So that right there is A to the n times B to the n. What is also cool about that, though, is if you have it backwards. Let's say you had A to the n, something with the base of n, times another something with the base of n, that it can become A times B all to the n power, just the reverse, right? So it's cool. This is going to be a lot of fun. We're going to have lots of fun with this in the future. It's really cool when you're simplifying really difficult expressions with it. You're going to have a ball. So anyway, what you're doing here, if we get a good example, let's say we have 4. Let's say we have 4 times 7, right? 4 times 7 squared. What that tells me is that I have 4 squared times 7 squared, okay? And we could actually calculate that. 4 times 7 is 28. So if you type in 28 squared into a calculator, or 28 times 28, you're going to get 784, okay? So once again, this is equal to 28 squared, right? Which is equal to 784. So let's see if it gives me the same answer when I do it this way. If I have 4 squared times 7 squared, that's going to be the same as, I'm going to work down on this one, it's going to be the same as 4 times 4 is 16, 7 times 7 is 49, right? So 16 times 49 should give me 784, and in fact it does. Ding 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 ding. So that is so uber cool, man. You're going to have so much fun with that later on. But you got to memorize these rules. If you don't memorize the rules, you're going to be sunk. And the faster you do it, the better off you are. The slower you do it, you're actually going to really hurt yourself. You actually might make it so that you don't learn the other stuff. Because everything in algebra really builds on itself. So you really need these basic building blocks to really master it, okay? So let's do another one here. Let's say I had 3. Oh, cool. Let's do that. Let's do a different color. Black is just always, if we're always using that, it can be a boring color. So let's go with teal. Ooh, I like that. Let's do that one. So we have 3x y squared all to the 3rd power. Ooh. So what this is telling me is I can take all of these and raise them to the 3rd power. So I get my 3, and I can raise that part to the 3rd power. I have my x. I can raise that part to the 3rd power, right? Because all of these are multiplied times each other. And I can take my y squared. What did it mean to do that? And raise that to the 3rd power. Now this is cool. Let's simplify it a little bit. So if I have the 3 to the 3rd power, that one I could easily do on my calculator. 3 times 3 times 3 is equal to 27. So 3 cubed is equal to 27. That simplifies easily. X to the cube power. Remember, this is the one, and we learned from the power to a power rule that if I have this number multiplied, if I have this power raised to another power, that I just multiply the two. So x1 to the 3rd power is the same as x cubed, right? Because 1 times 3 is 3. And then here I have y squared to the 3rd power. That's going to be 2 times 3 gives me y to the 6. And that is my simplest form for that. Now I know you were thinking, Mr. Sims, you had way too much fun without me on that. So I'm going to give you one of your own. I'm going to make this one a beautiful, let's make it a green color. Oh, I like that one. Let's do that. All right, so what we have here is we're going to have 4x to the 3rd, y to the 4th, all squared. Ready? Go ahead and give that a shot. Pause the video, give it a shot, and then see if you can conquer it. All right, what you should have gotten is you should have realized that there are 3 things that are being multiplied. There's a 4, an x cubed, and a y to the 4th. In other words, there's this one. Let me do that in a different color. There's this one here, there's this one here, and there's this one here. All right? There's 3 things. So what I'm going to do is I'm going to set my 4 here. And that is going to be squared because the rule tells me I can do that, right? I'm going to take my x cubed, and that's going to be also squared. And I'm going to do my y to the 4th. And that's going to be also squared. And what that gives me is 4 squared. 4 times 4 is 16. X cubed to the squared is x to the 6th. My brain just had a serious meltdown. Y to the 4th squared is going to be y to the 8th. Yes, it even happens to algebra teachers. So this right here is my final answer. Now, let's close it off with a good one for tonight, and then we'll call it good. So this is the final one for you. I'm going to give you this one here, and I'm going to try and make it a little tricky just because everyone likes to cry every once in a while. So 3x to the negative 4, y to the 7th, all to the 3rd power. All right, so ready? Go ahead and give it your best shot. Hopefully you gave it a try. Now let's see if you were successful or not. I really hope you were. You have a 3 cubed. You have x to the negative 4 cubed. And you have y to the 7th cubed. All right, so here you have 3 cubed. That means it's 3 times 3 times 3. So 3 times 3 is 9. 9 times 3 is 27. So this simplifies to 27. x to the negative 4 to the 3. I have to multiply negative 4 times 3, which is going to give me negative 12. So this is x to the negative 12th, and this is y to the 21. And you're done. What? Do I hear inward screams? Good. If you realize that you are not done, then I am so proud of you. Way to go. You are not done, in fact, with this. What you need to do is take this negative exponent and you have to change it. So your final answer ends up being 27 y to the 21 all over x to the 12th, because it moves to the other side of the fraction bar. And that is your real final answer. Well, I hope you've had a great time today. I hope you have learned a ton. As always, if you are watching these videos and you are doing what it takes for you to be successful, I am so proud of you. And I'm really proud that you're really taking your education in your own hands. I'm really excited when kids do that, because those are the kids that just take off and they blow themselves out of the water with what they are capable of. So you keep doing that. You keep being awesome as you are. And please, please, please bring me your work. I love to give prizes. I don't care whose class you're in. You bring me your work. I don't care if you are in 5th grade. If you bring me your work, I am totally, absolutely, 100% willing to give you something. It might not be much, all right? Because let's face it, I'm broke. But I will try and give you something, because I am so proud of you. And I always like to try and find a wall of fame or something that I can staple papers to so people can see how awesome you've been. So once again, bring me your work. I'd love to see it and just to see that you are doing an amazing job. Once again, thank you for watching, and I hope you enjoyed the video and that you learned a ton. Don't forget, there will be another video coming soon on actual practice simplifying some really difficult ones, and that'll be fun. We'll put all this together. Anyway, have a great day. Good luck on the tests.